Alright, so continuing the examples that we started yesterday. We're down to 13 through 16. It says to write a polynomial function of minimum degree in standard form with real coefficients whose zeros and their multiplicities include those listed. So number 14, we have -1, multiplicity 3. We have 3, multiplicity 1. So when we're going to set these up, okay, we know that -1 and 3 are zeros of the function, okay. -1 is a triple zero. Okay, that's what that multiplicity 3 means. So when I set these up, basically I have the factors then. So I end up with f of x is equal to x plus 1 cubed, because it's multiplicity 3, and then x minus 3, and that's just raised to the first, so you just don't have to write anything because it's multiplicity 1. And then you just go through and you multiply this stuff out. So this is really x plus 1 times x plus 1 times x plus 1 times x minus 3. So I would say group the first two, group the second two, just to go ahead and kind of make your life easier, or like less steps that you have to write. So what does this first two give me? And the other two? Alright, now I need to multiply these things all the way through, so I'm going to have a bunch of terms. So what does this give me multiplying all this through? Okay, and then now I just need to combine like terms. So x to the fourth. My x cubed terms are going away because they're opposites. X squared terms minus 6x squared. Just x terms minus 8x, and then just numbers, just have -3. So all you have to do is set these up, and then once you set them up, just multiply them. We'll set up 16, but we're not going to multiply it through. You guys can do that later or just not worry about it. I just want to set up another one. -1, multiplicity 2, and -2 minus I, multiplicity 1. Okay, and a lot of times I'll just write MULT for multiplicity. Okay, so if I needed to set this one up, how would I do it? Yeah, so this, you have to change the sign because this is like x is equal to -1, so then you want to get it on the other side, so it has to be x plus 1. So that part's squared, and then what about this part over here? And then you would just multiply that out, but we're not going to do that right now. Y'all can do that later if you are so inclined. Let's see. I was looking at, trying to check and see how they want these ones done. Next ones. Alright, so for 21 through 26, it says to state how many complex and real zeros the function has. So we'll look at 22. F of x is equal to x cubed minus 3x squared plus x plus 1. So I need to know how many zeros this is going to have, complex and real. So any idea how I need to go about doing this? Hold on a second. These actually might be the ones that are supposed to be done on a calculator, which in that case we're not going to do them. Okay, I'm just going to show you guys really quick just so you're familiar with it. I'm probably not going to give you any like this. But grab your calculators and type that equation into y equals. Make sure your stat plots are off if you have them on from anything. And then once you type it in, do zoom 6. Alright, so the fundamental theorem of algebra says a polynomial function of degree n has n complex zeros, real and non-real. Some of the zeros may be repeated. Okay, so what is the degree here? 3. So how many complex zeros do I have? Okay, so 3 complex zeros. And then I want to know how many of them are real versus non-real. Okay, basically, if it crosses the axis, they're real. If it happens like farther up, which we'll do one of those in a second, they are non-real. So all 3 in this case are real. Okay, if you were to zoom in here to this area, you could see that they all cross the x-axis. So they are 3 real. The fundamental theorem of algebra. Yeah, so whatever the degree of the function is, that's how many complex zeros there are. Some of them will be real, some of them will be non-real. Well, don't say the first one, because if I were to switch that and say 3x squared, yes, the one with the highest power. Just because, the only reason I'm saying be careful about saying the first one is because if I were to flip them, like last year, not like necessarily this exact problem, but I said something about like find the degree, and I had put like x to the 4th at the end, but they saw x squared at the beginning, and they said that there was degree 2. So that's why I'm like just saying like just be careful and make sure you look for the highest power, not what's in front necessarily. Basically, if it crosses the x-axis, we consider it real. So then here, yeah, the y-axis doesn't matter. It's the x-axis ones that we're looking at. Look at 24 really quick. I might give you guys one of these just to like look at in your homework, just to make sure you can do it. But I probably won't put any of these on the test, just because, I mean, you probably won't have your calculator for the test. So I'm not sure yet. You might. I have to look and see, but. Actually, you will need them for one problem probably, so you'll probably have to have it. But x to the 4th minus 2x squared plus 3x minus 4. So how many complex zeros do we have? Okay, 4 complex zeros. So then go type the equation in your calculator. Alright, so what do we notice about this one? Yes, there's only 2 real zeros because it only crosses the x-axis twice. Okay, it has other zeros, but they're non-real ones. So there's only 2 real in this scenario. You might be able to, but I'm not gonna like ask you for them. If you're finding non-real zeros, you're gonna be doing algebraically. Yeah. It might let you do it. I'm not positive. I've never tried to do that on my calculator. That particular thing. Okay, so then 27 through 32 says to find all of the zeros and write a linear factorization of the function. So, just lost my page where I have the. Basically, with these, we're going to go back and we're going to essentially do what you guys did in the last chapter. You remember that theorem? Well, it wasn't really a theorem, but where you used like the last term and you factored it, and then the first term, and then you found which ones were possible zeros. Okay. Basically, we're doing that, and then we're going to find if there's any like non-real ones that way. So, and then like write the linear factorization of it, which is basically just writing it in factored form. So, let's see. 28. I would say make sure you have a decent amount of room on your page to do it. So 28, we have, let's see, f of x is equal to x cubed minus 10x squared plus 44x minus 69. Yeah. Okay, so in technicality with this one, you have some options because there's not really a number out here, so it's going to be over 1. But I would say just for practice, let's still write out the different factors. So we're going to have plus or minus 69 over 1. So I'm not even going to write the stuff on the bottom as the 1. I'm just going to write my possibilities here. So what are factors of 69? Let's see, let's look at this. What does 3 go with? Can 23 come down anymore? Nope, so I just grab 23. and 69. Okay, and all of these are plus or minus. Okay. So now I would go to your calculator, type in this equation, and let's see which one is actually a possibility or which ones are a possibility. Okay, 3 looks like a possibility, so we're going to check 3. How do we check 3? What do we do to check it? Synthetically divide it, so 3, and then we write down all the numbers, so 1, negative 10, 44, negative 69. And then how does my synthetic division work? Okay, so 3 is 1, so we know that x minus 3, right, is going to be one of the factors. But I've still got to find what my other ones are. Okay, so rewriting this here at the bottom, what does this give me? X squared minus 7x plus 23. So now I need to factor this if it's possible. If it's not possible to factor it, then I need to use another method. Can it be factored? So then what would I need to do if I can't factor it? What method should I use then? Quadratic formula. So negative b, so that's negative times negative 7, so that's 7 plus or minus the square root of b squared, so 49 minus 4 times a times c, so 4 times 1 times 23. So what is that, 92? Uh, 4 times 1 times 23. For 4 times a times c. All over 2a, which is just 2. So this gives me 7 plus or minus the square root of, thank you, negative 43 over 2. So what do I need to do with that then? Take out an I. So this is 7 plus or minus I. Can anything come out of 43? Whoop. So now this gives me my other factors, right? So what are my other two factors then? Okay, yes, so then I have to subtract that stuff over to get x minus blah, blah, blah. So you're going to have, I'm going to go ahead and just write the whole thing down here. So we had our x minus 3 from earlier. Okay, now we have x minus 7. it doesn't matter which one is written first, so plus I squared of 43 over 2. And then x minus 7 minus I squared of 43 over 2. Okay, and if you wanted to split these things up to have like 7 over 2 minus I root 43 over 2, like as two separate things, that's fine too, but you can just leave it this way if you want. So we found the zeros, okay, so we had zeros here and here, okay, or, well, the 0, I guess, was technically 3, okay. So we had our, all the way up. So we had 3 was a 0, okay. We had 7 plus or minus I squared of 43 over 2. That was another 0. And then we wrote the linear factorization. When it says linear factorization, it just means to write it like this. Okay, big fancy word for just write it as like stuff in parentheses. Trying to decide. For stuff like 33 through 36, it says using the given 0, find all the zeros and write a linear factorization of the function. So with something like 34, okay, you're given 4i is a 0 of f of x is equal to x to the 4th plus 13x squared minus 48. And we need to find all of the zeros. So I know that one is a 0. So what do you think would be a good option for me to do to find the rest of them? How would I do that? You can't factor it yet. Huh? So synthetic division first? Is that what you're saying? Yeah, synthetic division sounds like a good first step. Okay, so you're going to want to use the synthetic first because we got to get this down to what we're looking for. And then once we get it down, then we can factor it. Okay? So keep in mind I'm missing my x cubed term and my x term, so I'm going to have zeros in there. So 1, 0, 13, 0, negative 48. So then what does my synthetic division look like here? Which is what? Which is? Okay, so 4i is in fact a factor. Okay. So now I'm left with, down here, x cubed plus 4i x squared minus 3x minus 12i. Okay, so I need to figure out some other, basically, factors here. Oh. What's another factor of this? Negative 4i. So now we can use this with negative 4i and do another one. And hopefully this will narrow things down for us a bit. So 1, 4i, negative 3, negative 12i. So what does my synthetic look like here? Well, the I would go away, right? No, it would have an I. So that's 0. So then I'm left with x squared minus 3. Okay, so negative 4i was also a factor. Now is this something I can factor here? Or do I need to factor it? Is 3 a perfect square? It's not going to give you, I have no middle term, so it's going to give you a middle term still. Could I also just set this equal to 0 and find my other x values? So this would give me x squared is equal to 3, x is equal to plus or minus the square root of 3. And let's just verify before we get too far that that's right. Yep. So now I need to write this as, or I need to write my linear factorization. So somebody tell me what that is. And then what else? Okay, so then that would be your linear factorization. Okay, not too bad. I know it's different. Okay, so there's about 15 minutes left. There's a little bit more that we're going to do with this section, but I feel like this is a good place to kind of stop and let you guys try a couple. I'm going to give you just like one of each type just because I know they're a little bit longer. If you don't feel like you know what you're doing after that, I would do more, but I'm not going to require you to do more if you are like, yeah, I've firmly grasped this concept. Just do the couple and call it a day. Let's see, so I'm just going to write it in here. 15, and don't forget you had the two problems I gave yesterday. I think it was 1 and 11. Okay, 23 is the one that you're going to do on the one that you do on your calculator. Okay, basically just how many complex zeros it has, and then if they're real or non-real. And then 2, 5. And then not trying to give you guys like super hard ones to do right now because I don't want them to take you forever. Actually, make that 29. If you can do 29, you should be able to do any of them that I give you. 33. Okay, just keep in mind with one like 33, okay, that's like what we just did. The difference is that rather than it just being like 4i, it's 1 plus I. Okay, so keep in mind that if 1 plus I is a factor, make sure you remember what the other ones would be. That you have 2 that you know, and then use that to be able to factor it down and find the other ones that you're missing. That's all I'm going to give you right now. So you have about 15 minutes. You can probably knock out at least a couple of them. Just You're not going to turn them in yet. I know originally it was everything was going to be like due tomorrow, but since we're going to add on a couple more, I'll just wait. But I would still suggest working on them now so that tomorrow when we move on with the rest of this section, you'll kind of know what we're doing because it kind of just keeps building.